Welcome back to the Grand Solar Minimum channel. Today is Tuesday, June 10th, 2025. Pardon me. Today we will discuss the status of Solar Cycle 25 and how surprising this forecast has actually turned out. There's a lot of interesting data that I've been uncovering. First, let's get into it. Our solar wind speed's coming in at 419.7 kilometers per second with a density of 2.82. So very, very moderate solar winds and a very light density. Yeah, baby, get it. All right. Our smooth sunspot number right now is at an 82. That's another thing that we're going to talk about as well that ties in with the prediction. Our KP indice is sitting currently at a 2, a 24-hour max of 3. So the last time we broadcasted, we came to you guys with all of the solar storms that was happening, the severe G4, and things have calmed down quite a bit since then. I also want to talk about cosmic radiation dosage rates. There's more to that as well. Currently, we're sitting at a negative 7.8%. That's our dosage rate. Now, the funny thing about that is that was the exact rate that we were at during our last broadcast during those extreme storms. The only difference is now that the 48-hour change on cosmic radiation has been up 2 point. So instead of cosmic radiation dosage rates dropping and being lower, we are actually seeing an increase in cosmic radiation over the past 48 hours and past couple of weeks. We'll discuss that as well. 5% chance of an X-class flare. Good. Keep things quiet for a little bit. Little bit of a recovery from what just happened. We're still digesting that data. And if you look at the TSI right now, it's at a 1363.0 watts per square meter. We'll also dive into that as well. But taking a look at our star right now, currently, if you guys will check out here, and I'll pull up an arrow for you to show you. But there is that large coronal hole that we have seen over the last 2 months, and it's triggered some pretty wild earthquakes and one volcano eruption, which I believe, well, I think the CME, the Halo CME, was responsible for the Etna finally blowing its top. But we will continue to watch this. And what's significant about this coronal hole, how we know it's going to be large, look at the corona outside of it. Do you see there's an indentation from where, and that means the coronal hole gets wider as it turns Earth facing, as we see, excuse me, that corona, the outer atmosphere, fading as this thing becomes more Earth facing. So this is going to be that large coronal hole that we've seen almost every 3 weeks that it reappears, and it does not seem to be getting any smaller. Along with the fact that we're seeing less and less sunspots. I had somebody tell me that the southern part of the sun was done and that we were going to see more action in the northern part of our star over the next few months, and that was 3 months ago. And we haven't really seen that. We're still seeing consistency out of the southern band. We do have a couple of plage and facula coming out this way here, coming from the northeastern limb of the star, but that has not been named yet as sunspots. At least on spaceweather.com, they are not naming this. Now, right down here is, believe it or not, 4105, right there. And there are some stars that we will show, or there are some sunspots that we will show you as well that is coming up here in the near future. So with that said, let's go ahead and dive into our first presentation I want to jump into, which is our TSI. I'll take a bigger look at this. Now, as you can see, we had a huge drop in TSI back in the beginning of May. And it was kind of shocking because of just the sheer size of how big this actually was. It was a good drop. Sorry, folks, having some technical issues here. So there's that drop that we had at the beginning of May, almost to 1361 even. Not quite, but there was a drop. Now I want you guys to pay attention to these drops and how far apart they are. As we see here, this was somewhere around March, and clearly the other drop is not here, so that could be sometime in April. So from March, the drop there that we had, until the next increase was a little bit further apart. So from March until May, there was almost a 2-month span and the largest TSI drop that we've seen to date. Then we went from the 10th of May, it looks like, until now. This image you're looking at is for June 10th. So we're seeing TSI in variations starting to shorten up. What do I mean by that? Shorten up by, in a sense that we're seeing less and less time in between the next dip in TSI. So here is the first dip, went by quite a bit of time, and then we saw from March until early May, it's almost 2 months of TSI holding steady. And then after this big drop, only a month before TSI drops again. Now, notice that the drop is not as low as we had here on May 5th, but we're still lower than what we were previously back in the beginning of March. So to me, this is also indicating the shorter spans that we have from, lowest point to lowest point. That means TSI is unstable and is not holding steady like we've seen it in months previous. Another indication that our sun is beginning to weaken once again. Let's take a look at the bigger picture here, as we are starting to see the one thing that strikes me about this graph, and I know some of you might be a little hard to see. Let me see if I can make this a little bit. I don't think I can, but I'll try. Oh, I did. I'll move it over a little bit here where the important parts are. But the one thing that sticks out to me the most is this is our peak all the way up here. And now we're starting to see our descend, but we're seeing some really big drops pretty fast right after the peak. Just as fast as it went up, it's going down. We saw an uptick in solar activity in 22 to 23 kind of quickly. And then I felt like it started to stall out a little bit here. If you guys notice, when we got into 2024, our TSI peaks are not as high as what we saw previously in 22 and 23. And then, of course, in 24 and 25, there's your peak. But we're starting to see this TSI drop down, I think, a lot more than what we had here. Climbing up to the peak, coming down from the peak. So even on the big picture TSI models here, or the charts, they are also showing a rapid decline. Now, even though right now we're sitting at 1363, which is, not the lowest. It's not the highest, but it's not the lowest. We will also see that number go back down. And by the time we do our next broadcast, I'm sure we'll start to see that declination. But so there's the first part. We have TSI showing data that is also lining up with a declining solar cycle. And then we go over to spaceweatherlive.com, and more proof here on this website about the rapid declining solar activity. First, let's share this real quick. This is the important part. All right, let me try to zoom in a little bit because this is kind of important. I know it's kind of hard to see with all these graph lines here. Let me see if that made a difference. And let's go in a little bit deeper. I think that's as zoomed in as I can go. All right, what's the point of this, right? Because so many people out there in the beginning of solar cycle 25 expected to see a cycle that was like this or slightly lower. Okay. And I can show you some graphs here in a minute too about predictions, but we were expecting to see totals right here. Now, obviously, solar cycle 25 did outperform its maximum, but the incline of activity was a lot more increased than it was in previous cycle. Like entering 24, obviously it didn't have far to go because it didn't peak out as high as 25. But just how fast everything happened, the solar cycle really came to life, and it came to life big time. But now we've already identified the peak, which was before the beginning of 2025. And since we have progressed into 25, heading halfway now into 26, our sunspot numbers, according to that, equals 72.9. Now that's the monthly mean, and I'll go ahead and show you where I get that number. Put my arrow here. I don't know if you guys can see that. Zoom out a little bit there. This is where we are right now in the current status of our solar cycle 25. Okay? This is likely where we should be and where most people had predicted. All right, you can go to spaceweatherlive.com and play around with this. But notice the difference, folks. Try to get that white line back. Look at the difference. I'm trying to keep this white line here. Sorry, this is tricky. All right, beautiful. Look at the difference. Since the beginning of this year, solar activity, it's a straight line. It's plummeting. The bottom is falling out. Even with a slight increase of sunspots moving into next week, we're still cutting this cycle off shorter than what most cycles appear to happen. Now, back in our 2019 interview with Valentina Zarkova, Valentina shared with us that we would see a rapid decline after the peak in solar cycle 25. In fact, she predicted it to be a little bit weaker than 24 along with some other folks, but she also shared with us that she wouldn't be surprised if there was a stronger output for the peak because it's not going to change what's going to happen come after the peak. Like I said, those are some bold words. And so far, what it's looking like, and we have many, many years to go before we get to 2030. We got 5 years. But when we look at this graph historically, we don't see at any point in time where solar activity falls off a cliff like this. Not in solar cycle 24, where it had two. If you guys look here, where I put the thing at, we got two, massive drops in solar activity during the solar cycle 24 peak, but nothing where it didn't rebound and slowly made its way back down to the minimum. Okay. And then we go back up, and things happen rapidly on the way up, for sure. Sunspot number peaked out, the mean anyway, at 160 something. All right, let's get to the top of that. 190, 191. 192 was a prediction of what we would be at, and we actually surpassed that if we go to the very, very top. It won't let me. It's being a jerk. So above predicted sunspot activity during this cycle, but the one thing that I find fascinating is that how we are sitting at a 79.2. And folks, 2025 was the year of the peak. So this peak came earlier. The cycle started earlier as well. So I feel like that this was a steep climb. And now we are looking at even an unprecedented drop. Now, I guess the big question is to watch this graph, okay, and see if it spikes back up. Now, we have the tools to see if that's going to happen or not. So let's say to get back up again to the 140 range, you'd have to see that line jump up to here a little bit. Is that doable? 140 number on the sunspot. Is it doable to see it go back up to here? To see over 100, so if we had a day of 142 sunspots where my red arrow is, that's what we're talking, all the way up there, 140. So is that doable from where we are right now? Well, let's take a quick look. I can show you where we are. I might have to switch. Yeah, I have to switch the. Lots of stuff here, guys. Lots of stuff. Here, check it out. So on here is a look at far side activity. And as you see, this is current. This is Earth side. Okay. This is what we're dealing with right now. Earth side. This is the far western limb. So there's a sunspot, some light sunspots here, and then nothing much coming on the back end. Maybe some action up here, but not a lot. So based on what we're seeing right now, if our sunspot number is at 82 with this action, and we don't see anything on the eastern limb or the western limb, is it possible to see the sunspot number go back over 142? I'd have to make an educated guess and say no, that's not possible. Looking at this, it's very, very light. The sunspot, let me see if I can zoom this in a little bit more. Nope, it won't let me. So check it out on spaceweatherlive.com. You can see for yourself where it says far side. It'll show you the action we have on the western side of it and, of course, the eastern limb. So, in my opinion, looking at the sun and the SDO, it doesn't appear to me that we're going to see an increase in sunspot numbers. Basically, they would have to double what they are right now to get that line that we were just showing you, to get that line to go back up versus staying here. Like I said, I think it's more reasonable to see it to hover around the 100 mark and then come back down again. Maybe. But to what I'm seeing, as these current sunspots that are rotating to the western limb, those are going to fall off and the count's going to go down from there. So what's coming around the bend now on the eastern limb does not, to me, I'd be shocked if we got it up to 100 for our sunspot number. Now, that would be more of a reasonable climb back into declining. But indication to me, if we're doing this drop for as many days as we have, and I'd say this is a good 2-3 week timeline of how much sunspot activity has fallen off. And never before have we seen it drop so low from such a high point. I mean, it's almost taken us back to where we were in the cycles, probably somewhere around 22, late 22, early 23. So almost 2 years. The time it took for it to climb from there to get to the peak, it dropped in 6 months. So definitely something to keep our eyes on. And here's where it motivated me to get back on air and show you guys something real quick. Let me zoom this in, try to center that a little better for you. Okay. So over here is a chart that Zharkova had in one of her papers from 2015. And by the way, you can find this information on Valentina's website. By the way, Mari is the one who is responsible for getting the website built, putting up the content in the beginning, and so credit to Mari, good job. And this website is still up and operating, so that's the good news. But here is like a rough predictions of the cycles that are coming up. Now, here's solar cycle 24, there's solar cycle 23. Obviously, she actually originally had solar cycle 24 to be the stronger cycle, and then 25 would be weaker. Well, that didn't happen. 24 was the weaker, and 25 outperformed 24. But here's where I'm going with this. Look at the declination that she has predicted after the peak. Almost identical to what we are seeing right now. And you can go to Space Weather Live. They'll show you the real-time results. But look at that drop in solar activity. Here's solar cycle 24. It dropped, and then it came up a little bit and dropped again. And then she's got solar cycle 23 with a drop, a couple dips here. Big drop here in solar cycle 22. But always kind of came back and getting into another maximum. Obviously, this was a very large drop from the peak of solar cycle 21. Look how far that goes down. So we have shown these decreases before, and they continue to happen. But the point I'm trying to make is that the case here in 25, the prediction she has is that these next cycles coming up aren't going to be anything. Solar cycle 26, she's predicting a smooth number of 50 for that whole cycle, and then it gets below that during the 2030s into the 2040s. The length of how long these lower outputting sessions will be is alarming compared to what we've had in the past. But this is where Valentina Zarkova, now this is 2020, she predicted around 2025 for the peak, which is right there, and then a sudden decline as we headed into the 2030s, and then minimum peak by 2035. Look how low that peak is, and we fall back into a long period until the next solar cycle. So she has solar cycle 25 predicted to be shorter than average. In fact, if you really want to look at it, the cycle as far as the next cycle beginning is somewhere around 29, and 19 is when this cycle officially started. So this would be a 10-year cycle approximately. I'm not putting the exact numbers on this, but this is the proof that I'm always talking about, how Zharkova has predicted this drop in solar activity so sharp, and it doesn't come back. It stays minimum conditions before it starts the next cycle in cycle 26, which she has it beginning sometime in 28 and peaking somewhere around 2032. And that's a lot earlier than some of these other forecasts. But again, if this trend continues, and like I said, I'm taking an educated guess at this, but when I see the far side sunspot numbers, I lost that page. Hold on. Phooey. But this is how I'm making this educated guess. Looking at what we have coming, it's circled right there, B72. There's another red circle leaving, another section leaving. Okay, there, you guys can't see it, but there's a faint sunspot here and a faint sunspot here and a couple down here. We're not seeing this increased activity across the northern hemisphere of the sun like folks had previously stated that we should have had. They're right. I mean, it should have rebounded, but what we're seeing is proof that it didn't rebound, And as of right now, we're looking at some super low numbers at this particular point of the minimum. Now, it is possible, as we see here, like I said, we've seen lower drops before, and then it goes back up to a peak, okay? But I just don't see that evidence being supported right now based on the far side sunspot looks, based on the SDO images that we're looking at. Right now, this trend should continue as sunspot activity will continue to drop, and I would not be surprised to see a lower number than this tomorrow, moving into Thursday as well, regardless of the size of the one that's Earth facing and looking straight at us right now. Another thing I wanted to talk about, how we know that this solar cycle, even though it shows more sunspots, it's still weaker. Here we go. The biggest forebush decrease in 20 years. Now, they're not mentioning the biggest one, which was farther back. And this just shows me the declination. So the last 20 years, when we had that CME that was a halo, our cosmic radiation dosage rates were on the negative 19%. Okay, here's the day the article came out. It was still at a negative 17%. All right, why were we so low in cosmic radiation rates? Obviously, when we had over 1,000 kilometer per second solar winds, it brushes away any existing cosmic radiation that's around our planet and kind of cleans it up for a little bit. And that's why we saw such low dosage rates for those few days. They're now coming down, or I should say they're going up, which means when the cosmic rays are going up, that means we are going to see more low solar activity interactions with our atmosphere, more rain, more cloud coverage, lower temperatures. The more cosmic radiation dosage rates we get, the more seismic activity, the more volcanic activity. So that is something to watch. But the lowest that they have on record, according to satellite data, is in 1991, which was the lowest rate of 32.1%, which means we had a very strong magnetosphere protecting us from cosmic rays back in 1991. So this is all coinciding and lining up with a weaker sun that's still showing decline throughout decades of data. 32 was probably the peak, because 1980, that cycle was pretty active, and we had quite a bit of sunspot numbers. So we had a strong connection to our sun, which strengthened our magnetosphere and protected us from those cosmic radiation dosage rates in that maximum during the 90s, the early 90s. But in 2009, we saw some of the strongest cosmic radiation dosage rates, over 11.7% compared to these negative numbers. And even these negative numbers to this day can still have an impact on the current weather situation here on Earth. But I thought it was interesting that all that solar wind that we got was from this CME, and that this is the biggest drop in cosmic radiation numbers since 1991. All that means is that this was only half of what we saw in 91, which means we're not as strong as folks think we are. When the strongest protection from cosmic radiation dosage rates is 17 to 19% versus the all-time high at 32%, and it dropped from that high, that shows a trend that it's going down. Just again, educated guesses, watching the data, putting it all together. This is not wild guesses or imagination issues here. These are facts based on tools that we could all use at the same time by going to these websites. Sunspot numbers have increased actually since we started this broadcast to 95, but look at all the sunspots that we have over in the far western part of the sun. 4100, 4101, 4099 are getting oh wait, I'm sorry. I'm a goof. This was a dated story from June 4th. Obviously, we're not in those numbers anymore. Let's something didn't look right. Let's refresh it. And we're refreshing. And it's not doing anything. Love technology. But the point I was trying to make is that as we go through this cycle and we zoom out and look at the bigger pictures, we have indications. We have indications that cosmic radiation dosage rates are down, but they're not as down as they were in the last major maximum that we had. So there's an indication of weaker sun. And then you have the TSI factor, where we're starting to see TSI rates starting to be shorter when it comes to long range consistency with TSI. That is not happening now. The dips are coming more frequently than 2 months, 3 months at a time. These last two big decreases that we did have happened in a month's worth of time versus previously at 2 and 3 months. So we're seeing signs with that. And of course, what I showed you with Valentina Zarkova's, her sunspot predictions, her solar cycle 25, where she thought was going to happen with solar activity, dramatically dropping. So there is, now that's 3 things that I've showed you guys that all correlate with this big drop in solar activity. In fact, she might have oversold her prediction, because right now that line is heading a lot further straighter down than what she has it. Again, PhD scientist with a master's, she's a PhD astrophysicist and a PhD in mathematics. And that's how this information is being compiled. She's taking empirical data and running her calculations on them, and this is how she's coming up with her predictions. And she predicted this image right here is from 10 years ago. So she was a cycle ahead of us before we even knew what was going to happen next. That, to me, is accuracy. And the reason why she got so much flack with her Nature publishing, where she had a calculation that was slightly off, but it had nothing to do with the overall conclusion. They were picking and combing through her paper, trying to find something that would disprove that solar activity is responsible for climate change, because it went against all the narrations of it all. She fought hard, and her work is paying off. Things are coming to fruition that she has already said 10 years ago. So the added humidity and cloud don't help the fungus either. No, Helene, actually, that's funny that you mentioned that, because I was a little grossed out in my backyard sitting out there at the cookout, and there's all these little tiny ugly looking mushrooms. They weren't like the cool looking ones. These look like they were nasty or something. But you're right. The humidity, the moisture. And that's another thing I want to bring up quickly. I didn't put it in my presentation today, but the moisture from Tonga is creating this abundance of moisture in our atmosphere. If you live in the Ohio Valley in the Northeast, you'll notice a pattern of just rain, wave after wave after wave of rain. And another interesting fact too is that here in the Northeast, we haven't seen a dry weekend since the middle of November 2024 of rain or snow. So there are an abundance of rain and moisture because of Tonga. 2022, we are still feeling the effects from that. Remember, when that thing went off, it went up to like 110,000 feet into the atmosphere and put record amounts of moisture in parts of the stratosphere that it doesn't get moisture. So it's off the charts, guys. It's not just like a strong. It was off the charts. They didn't know how to color code it because it was so strong and so long of a duration. And I believe that with the flux of cosmic radiation that we get, some days are better than others, but you can tell when the cosmic radiation dosage rates go up, so do our chances of rain. So a lot of correlation here, folks, about the weather and the impact from the sun. Now, temperatures. Let's move on to that real quick. Water temperatures have not changed much since the last time we did a broadcast. The majority of this area was already in the low 80s. Some have crept up to 83 degrees, but the majority of those 83s were 82s. We have one warm spot in the center of the Gulf, was 84 degrees. Everything else right now is where it should be for this time. Might be a little bit behind, I don't know. But I wanted to show these water temps because the last time we did a broadcast, they were right around where we're seeing right now. Staying on the subject of temperatures, here is Roy Spencer's monthly report. And I'd like to take this opportunity to give my best, my prayers and thoughts, along with Mari and I. Our thoughts and prayers are with you and your family during this time. And we are so sorry for your loss, Roy. But back to the show. Mr. Roy here contributes to us the global temperature report. And in the month of May, we saw a drop of 0.11 degrees in the south, in the declining range. So temperatures have continued to drop since that anomalous peak that we had in the middle of 2023. I believe a lot of that temperature spike had a lot to do with the amount of moisture that was in the atmosphere. And the peak of our cycle was around 2024, early part. So this all lines up. Solar output, moisture in the upper atmosphere, concentrates that sunlight into warming things up. Atmosphere's temperatures were up and down a lot, and there were a lot of more stratospheric warming events than I've seen in the last couple of years. And I still believe that Tonga is still having its effects on our climate right now, even though it blew 2 years ago or 3 years ago. The amount of moisture that it emitted is still having the effect because of just how monstrous it was. And it was an underwater volcano. That's why we had all the water vapor. So if anyone is wondering how water vapor got that high, this was a powerful eruption from a volcano beneath our ocean. If it's pushing up ash clouds to 100,000 plus in the atmosphere, imagine what this thing could have done from land. This is the kind of eruption that changes climate for a short period of time. And when I mean time, I mean years, possibly decades. So we have a lot going on, guys, and the decrease in solar activity is contributing to more rain, more cloud coverage. Temperatures are dropping. Here's the proof. We're definitely seeing a massive drop ever since the peak of 24. As the peak of the solar cycle dropped, so did temperatures. So did TSI. So there's so many correlations right now that explain the reason why solar activity and climate have something to do with each other. And also, let's not discredit the work that Roy and John Christie did on a paper that talks about urban heating being the reason for these global temperatures going up. Our Urban Heat Island paper has been published. And the reason why I want to mention this is because there is some correlation to this. Think about it. You saw temperature rise really starting in the 1850s, slowly start from there and climb ever since. Why is that? Well, think about all the concrete asphalt construction that we have put on this planet since 1850. Think about what the sun does to asphalt and concrete. It absorbs it. It holds that energy, and it creeps up the temperature a little bit on the surface, especially when you're dealing with highly populated cities. The longer we've been in existence, the more asphalt, the more concrete, the more material that the sun has to absorb and create this warmth. And I've kind of firmly believed this for a long time as well, that the construction of concrete and asphalt has definitely contributed to minor temperature changes throughout the history of our civilization. That is the proof. So the less we build, then we can start to see this man-made effect start to taper off as we continue to create and build more construction with concrete and asphalt. The question is now, can we figure out a new technology that helps reduce the absorption of solar rays and keeping that urban heating? That's going to be the next challenge, is how do we build with materials that won't create such a heat island like we see as we are experiencing currently in our civilization. So there, I'm willing to say that this is a very reasonable paper. I don't think there's anything wrong with what they're saying here, that humans contributing to temperature rise based on the fact of, construction of concrete and asphalt. I don't think there's a problem with that at all. But I think the main focus, aside from that, and with a weaker sun, weaker absorbing obviously too for our concrete, so that'll keep temperatures low as well. But I think the main focus that I want to keep going on this channel is the effects of what solar activity does to the planet. And you decide, is it a coincidence that all these other things are falling hand in hand with each other? Is it just a giant coincidence? You decide. But I'm here to present the evidence that shows the correlation of all these graphs and these charts that show declination increase when we're in the peak. We also see it in our temperatures as well. It's common sense. If solar output is at its max, we're going to have warmer temperatures. There's more output. There's higher TSI. When the sun is not producing as much TSI and it's not as bright and it's dimming because of the cycle, it's taking a nap, basically, is what the sun does before it charges up for its next big cycle. So it's not too complicated. It's not rocket science. There is a lot of things to go through, and I leave that to the scientist. I leave that to Zharkova to come up with the calculations. You're not going to see me working out formulas and that. No, I'll leave that to the trusted experts, the John Caseys, the David Dilleys, the Valentina Zarkovas, the Heinrich Svensmarks of the world. Let them do it. They did a great job in the beginning. They're the ones that set the foundation for all of this. And if you haven't read the book Upheaval from John Casey back in 2019, it's worth a read. A lot of the things that he was talking about back then are happening right now. And I promise you, if you read the book Upheaval, it's going to make sense. It's going to make a lot more sense what I'm saying to you right now. Also, guys, if you want the link to go to Valentina Zarkova's informational Grand Solar Minimum page, this is the one that Mari created for her to pretty much produce all of her work on. That way it's not going to get censored anywhere. This is all of her work. This is all of her peer-reviewed. You can go to the sections like energetic particles, all kinds of stuff that she's doing right now. Zharkova is a very busy scientist, retired from teaching, but she is still very much involved with producing papers and helping us adapt to what's happening and understand what's happening and what's going to happen. I think Zharkova is fair. She also states that by 2100 we'll be going through another global warming situation. She's admitting that, and this is solar inertial motion, this is why she is calling for that global warming by 2100, because of SIM. So the lack of SIM is cooler, and the abundance of SIM is going to be the reason why we start to see. So she's already telling you that the sun's going to warm us back up after this grand solar minimum cycle that we're getting ready to hit. We're going to have a rebound by 2100. Are we going to be here? No, but our grandchildren and their kids will be here. And what we do right now is all about prepping our future generations and helping them understand what's happening, and that there's nothing to panic about. We can get through this. There are ways to adapt through this. We just have to be smart in our planning, because future generations are going to go through this again. We're going to be long gone, but future generations will be involved with these types of situations for sure. All right, let's go back somewhere real quick and take a look at a live something. Now let's go back to the Spaceway this station, because I want to say hello to everybody into the chat before I wrap this up. I want to say hello to our mods, of course. Knife Collector, good to see you out here. Mari for keeping the chat in line as well. Good to see you, Jerome, as well. And I appreciate our mods that show up Again, they are volunteers at all times, but they're here to help keep the channel running nice and smooth, and we always appreciate that. Some of the viewers that are out there, familiar faces. Helene, hello. Melody, good to see you out there. Carlos Ramirez, nice to have you here, sir. Melody, of course, long timer here. Anthony, good to have you in the chat. A lot of other people. Jason Schmidt, another long-time person. Carlos Ramirez, he definitely understands Tonga plus Gulfstream, further north AMO plus. This guy is a wizard when it comes to the ocean cycles and all this other AMO stuff that he talks about a lot on Twitter. So very reliable source, very credible. He knows his stuff. Green and White out there from Ireland. Thank you for tuning in and checking us out today. Glad you were able to make it. We have a lot of people from over the pond, so I know what kind of crowd we're pulling in here if we do a show at 11 o'clock. Peter Aeronaut says, what about the coronal holes? The coronal holes are going to continue to get larger as we move through this into this maximum cycle. And as you see, that persistent solar or that persistent coronal hole in the south, it does appear that it shrinks a little bit each time it comes around to us, but the only part of it that's shrinking is the part that's in the center of the Earth. The lower part, to me, seems to be getting longer. So we are seeing more proof of more coronal holes as another indication of a weaker coronal atmosphere for them. And to everybody else who tuned in today, thank you so much. We appreciate the support of this channel. Please stay tuned. We got tons more content to bring to you guys. There's more to be talked about this week and possibly on the weekend as well. Things are definitely getting interesting out there. And some of these predictions that were made about Solar Cycle 25, some of them didn't come true. But I think the meat and potatoes of the predictions, especially the ones from Valentina Zarkova and the educated guesses that we share here at the Grand Solar Minimum, are based on information from people like Zharkova. And to me, I feel like this drop, as steep of a drop it is, regardless if it comes back to 100 sunspot number tomorrow, the fact that it was such a large drop from the maximum period is what's impressive, because that technically, we're about 2 years ahead right now when it comes to solar activity dropping like that. We're 2 years ahead of where we should be. So lots to think about. But again, thanks for tuning in. Make sure you guys check out our other videos. If you're new to the channel, please like and subscribe, share this, drop a comment. Let me know where you're from. Let me know what you'd like to learn more about. This channel starting to try to make a comeback per se, and I know we'll get back into more talk about crops and everything like that moving forward, but there's just so much scientific news right now about the sun that we could do separate shows on the other effects like the crops and everything like that. So again, thanks for tuning in, and I hope you guys have a great day. Until later, we will talk soon. Take care, guys.
Do you like this show? Give us a thumbs up. Want to support us more? Share to your favorite social media platform, buy a t-shirt, or become a Patreon. All links are